In this video, we'll show how we can sometimes use factoring by grouping to create a difference of squares and factor what may have at first looked like an unfactorable trinomial. So, sometimes we're given a seemingly unfactorable trinomial, but we can factor it if we create a difference of squares. This method can be employed in each of the following trinomials and many others. So x to the 4 plus 7x squared plus 16, x to the 4 plus 6x squared plus 25, 4x to the 4 plus 19x squared plus 49. Each of those on first glance may look unfactorable. But when we have a trinomial that has powers of x equal to 4 and 2 and 0, or I should say here the exponents of x are 4 and 2 and 0, and the first and last terms are perfect squares, we can attempt this method to see if it works. So for instance, look at this first trinomial. The exponents on x are 4 and 2 and 0. The second one, the exponents on x are 4 and 2 and 0. And the third one, the exponents on x are 4 and 2 and 0. Also, the first and last terms are perfect squares. So in the first one, x to the 4 is x squared quantity squared, and 16 is 4 squared. In the second one, x to the 4 is x squared quantity squared, and the constant term is 49, which is 7 squared. And finally, in the third trinomial, the first term is 4x to the 4, which is 2x squared quantity squared, and the last term, again, is 49, which is 7 squared. So suppose we're given x to the 4 plus 7x squared plus 16. Our exponents are 4 and 2 and 0, and we have a first term of x squared quantity squared and a last constant term of 4 quantity squared. Well, since we have x squared quantity squared and 4 quantity squared, let's see what x squared plus 4 quantity squared equals. Okay, well, x squared plus 4 quantity squared is x squared plus 4 times x squared plus 4, which is x to the 4 plus 8x squared plus 16. So we were given x to the 4 plus 7x squared plus 16. If we can just change it to x to the 4 plus 8x squared plus 16, we might be in business. So that's what we do. We actually change it to x to the 4 plus 8x squared plus 16. And that is the same as saying x squared plus 4 quantity squared. But we added an extra x squared, so we have to subtract that at the end. So x to the 4 plus 7x squared plus 16 is really x squared plus 4 quantity squared minus that extra x squared. Well, look what we've just done. We created a difference of squares. Okay? So that means we can say it's x squared plus 4 minus x times x squared plus 4 plus x. Let's go back again. When we have x squared plus 4 quantity squared minus x squared, we have x squared plus 4 minus x squared plus 4 plus x. Okay, and now, of course, we like to rearrange our trinomials. Each of those two factors is a trinomial, but we like to put them in the proper order. We get x squared minus x plus 4 times x squared plus x plus 4. And of course, it's not a bad idea to look at that and see if you can factor either of those. In this case, you can't. We move on. So what if we were asked to factor this expression, x to the 4 minus 23x squared plus 49? Well, we see that our first term is x squared quantity squared, and the third constant term is 7 quantity squared. Now, we could ask ourselves, what is x squared plus 7 quantity squared? Because we've got x squared squared and 7 squared. We could say, what's x squared plus 7 quantity squared? But if you look at the original question, the middle sign there is a minus. So instead, let's try figuring out what's x squared minus 7 quantity squared. Well, x squared minus 7 quantity squared will ultimately be x to the 4 minus 14x squared plus 49. So we were given x to the 4 minus 23x squared plus 49. We're going to change that to x to the 4 minus 14x squared plus 49. But of course, we still have to subtract the extra 9x squared. So we can say x to the 4 minus 23x squared plus 49 is x to the 4 minus 14x squared plus 49, aka x squared minus 7 quantity squared, minus 9x squared. Now, we have here a difference of squares because 9x squared, as you see in the last line on the slide, is actually 3x quantity squared. So we have x squared minus 7 quantity squared minus 3x quantity squared. Well, if we're going to use a difference of squares there, we see that we'll get x squared minus 7 minus 3x, x squared minus 7 plus 3x. And that's what we have on the next slide. X squared minus 7 minus 3x, x squared minus 7 plus 3x. And then, of course, we like to reorder each of those trinomials in descending powers of x. And finally, let's try this one. We have 4x to the 4 plus 19x squared plus 49. Well, the first term here, 4x to the 4, is really 2x squared quantity squared, and the third term is 7 quantity squared. So since our middle term is a plus sign, we'll try that first. Let's determine what 2x squared plus 7 quantity squared is. Bashing that out, we get 4x to the 4 plus 28x squared plus 49. Well, that means that instead of being given 4x to the 4 plus 19x squared plus 49, we wish we were given 4x to the 4 plus 28x squared plus 49. So let's make it that. Let's say that's what we were given, but then remember to subtract that extra 9x squared at the end. If we do that, then we can say 4x to the 4 plus 19x squared plus 49 is actually 4x squared plus 7 quantity squared minus 9x squared. Well, as we saw in the last question, 9x squared is really 3x quantity squared. So we have 2x squared plus 7 quantity squared minus 3x quantity squared. This is a difference of squares. So that's going to factor to 2x squared plus 7 minus 3x, 2x squared plus 7 plus 3x. Okay, and we write that out, and then we reorder each of our trinomials to be 2x squared minus 3x plus 7 and 2x squared plus 3x plus 7.